Our technology, right? DNA, which is contains the fundamental idea behind the whole invention. It's based on rotation, high G. So we have an electric motor running and giving rotation to a rotor like this. This is a rotor with a rotational axis going like this, and we have inlet close to the center. So it's in, and our fluids go through the inlet, out to the periphery, along the periphery, back into the rotational axis, and then out. So, and it's the same on the other side here. You have inlet, you have out to periphery, along periphery, back to center rotational axis, and then out. Rotate. It's a rotor like this. And all our processes are happening in this region, in the cylinder along the periphery, where we have high G, we have high pressure, we have high temperatures. So when it's a gas, you get this high temperature you get from high compression, etc. And this is within this principle, we have done water electrolysis in the RotoReformer. We have done heat pumps, so the process is heat exchange, and we're now going the reforming process within this same principle. The first project I worked with together with Åge was the RotoReformer, the rotating electrolyzer. So we produce hydrogen by splitting water with electricity. The RotoReformer is based on the same principle here. With the RotoReformer we have what we call electrodes out here. We add electricity with the brushes, plus and minus, and then we have so this is the whole end section here is minus, this is plus, and then we have the electricity going through these electrodes. And out here we have high G, high pressure, and then when you produce hydrogen and oxygen, all the gas goes towards the center. It's the same here. These are discs going all the way around, and you produce H2 and O2. So it's plus minus electricity on the electrodes, and then we separate H2 and O2 in the center, and then we can let out the H2 here and the O2 here, or in separate channels. There are different solutions for this, but the principle is the same. We spin the whole rotor with the electrodes inside, and then we get produced hydrogen and oxygen, and we collect it in separate channels, and we lead it out separately. And we showed by the prototype, or even almost pilot, we finished in 2015, that we could reduce the size of the cell stack by a factor of 100. Even 200 is the volume of this cell stack. And the efficiency was very high, and we could. It was very flexible. It started in seconds, or in less than a second. You switch on the electricity on the brushes, and out comes the hydrogen and oxygen. So the chemical reactions in the RotoReformer consist of two main parts. It's the SMR. Steam Methane Reforming, which takes methane, CH4, plus water, and it converts it to carbon monoxide plus 3 hydrogen molecules. So you take the methane, the carbon with 4 hydrogen atoms, and the carbon reacts with oxygen, and then you get 3 hydrogen molecules for each methane molecule. The next one is the water gas shift reactor. Then we take this CO plus more water, H2O, and it goes to CO2 plus another hydrogen. So altogether we have methane plus 2 water, and it turns into together. I'll write like this. Together you have CH4 plus 2 H2O goes to CO2 plus 4 H2. So you have 3 hydrogen from the first process and 1 more from the second. And then it's turned into CO2 and hydrogen. And the next step now is to separate the CO2 and the hydrogen. And that can be done by several different methods. The usual way of doing it is by amine absorption cycles, but we intend to do it by compression and cooling, because if we compress and cool this mixture, then the CO2 will rain out, same as water is raining out of the atmosphere. Here the CO2 will rain out of the mixture of hydrogen and CO2, and the liquid CO2 contains almost, the liquid in this process is almost 100% CO2. There will be parts of hydrogen in it, and we will not get 100% of all the CO2 out, but it's a very good mix, and we will do all of this within one rotor, and by compressing and cooling this, we get the energy back, because this SMR reaction needs a lot of heat, a lot of energy. It's what's called an endothermic reaction. So you need to put a lot of heat into this to split the methane into CO and hydrogen. The second process is producing a little bit of heat, but altogether you need to add a lot of heat. And we get part of that heat energy from the products, from the mixture of CO2 and hydrogen, and we take that energy and put it back into this first endothermic reaction. And that's in short why we expect to get very, very high energy efficiency in this, in addition to make it very compact. And we also handle this CO2 capture as a part of the process. It's not a separate process that comes after the SMR and VGS. It's within the same rotor. And that's this is an explanation of the basic principles we use in our RotoReformer. So this is a rotating rotor with an electric motor running, and then we have the inlet on one side. It goes in at the center, then inside the rotor it goes out to the periphery side, and this is where our process is happening on the periphery, which of course goes all the way around. And after the process happens, it goes back into the center and out. So this is a situation where you spin up all the masses going from the center and out. So here it has a very large kinetic energy, a lot of the high speed, and then the process happen in this periphery section with with a high G, high artificial gravity, so that you can speed up a lot of processes like heat exchanging and chemical processes. Then when the masses go back into the center, it stops from the huge, very high speed to very little speed in the center, and then it goes back up or out of the rotor. So this is in fact a compressor, because when the flow is slow here, you get higher pressure, relatively constant pressure along here, and then you have a reducing the pressure by giving the energy back to the rotor. So this is in effect a turbine. This is a compressor and this is a turbine, and these, you have the same mass flowing through every second at every point in this rotor. So there's no net cost in having this high G, high pressure condition at the periphery when fluid is flowing through the rotor. So that's the main principle in all of our rotating device applications of this principle in the RotoGenerator. So in here we have this the one RotoReformer rotor, which is within this gray box, and in the larger box we also include a fuel cell to generate electricity from the hydrogen. So this works by you have methane coming into this either liquid or gases, methane, natural gas coming into here, and you have water coming from that blue line into this steam methane reforming process. You're heating up everything with a heat pump, and then in this reaction the methane reacts with the water, and then it turns into 3 hydrogen molecules and 1 CO molecule, and then the additional water. This mixture goes further to the water gas shift reactor. In the water gas shift reactor, the CO reacts with the water, and then we get CO2 and an extra hydrogen. So from the 3 molecules here, we have 4 here, and then we have the extra water going through. So this mixture goes into the separator, which is a cooling process where first the water condenses out, rains out, and it's returned to the SMR reactor, and then the CO2 is liquefied and raining out, and it's taken out of the box. And then the only thing left is hydrogen. This hydrogen goes into the fuel cell, which produces electricity and water. So you have hydrogen and oxygen coming into this fuel cell. Out comes water, but it's twice as much water as you need. So you have water coming out here and water returning the same amount, 2 moles of water for every mole of methane, or every molecule. Okay, and then by combining the reformer and the fuel cell, if we take care of all the heat coming out of these processes, then we add this heat together into the heat pump and feed it to this endothermic steam methane reforming reaction. So by doing this, we take care of all the heat inside, and we get out electricity. Part of this electricity is taken to run the heat pump, the compressor in the heat pump, but the rest, which is the rest of the electricity, can be used elsewhere. Within these 2 boxes, everything that enters and leaves the boxes is from these arrows. And if you look at the whole RotoGenerator, all the heat produced in the fuel cell, in the separation, in the water gas shift reaction, is returned to the endothermic SMR reaction. So this is recycling all the heat energy inside. We're also recycling the water, so we don't need to add water from outside. We're actually producing water from this box.
Can you tell us a little bit about the efficiency?
If we look at the efficiency of the whole reaction converting methane into electricity, efficiency can be defined in different ways, but one way is to see how much heat is wasted, because heat is the normal way to waste energy. And in this case, we probably have to add heat to this. So by adding low temperature heat, we can convert it in the whole process here into electricity. So in principle, you can get this RotoGenerator up to 100% efficiency. That's our goal in this, and that's by feeding energy in the form of low temperature heat into the process. This picture will show that in addition to the RotoReformer, which has a methane as the feedstock, we can also have any carbon containing feedstock from waste, for instance. Then we first need to do a gasification of this, but with high temperature. Same principle here. We use the heat pump to heat it up, and then out of this carbon gasification or water gas reactor, we also get this syngas. But here we have twice as much CO and 2 instead of 3 molecules of hydrogen. And the same way we have additional water. This syngas goes same way as it did before into the water gas shift reactor, where the CO converts to hydrogen, and then we have same way we have 4 hydrogen, but then now we have twice as much CO2 plus the additional water. Then we have the separation. We return the water. Now this time it's up instead of down. We return the water to the gasifier, and we take the heat out to the heat pump loop, and the CO2 comes out liquid because it's cooled down and pressurized. So it's liquid, so it's raining inside here. Same way as before, we have the hydrogen coming into the fuel cell. The fuel cell produces electricity from hydrogen and oxygen, and the water, which now we need everything back to the gasification reaction. We don't have an outlet of water from the fuel cell. So this is the closed loop to produce electricity from carbon or carbon containing things, but we need to handle the gasification. Maybe outside the rotor, or if it's pure carbon, it could possibly be done inside the rotor.
Has this law or this process been verified by any institution in Norway?
Yeah, this RotoReformer principle, where we take care of all the heat and where we produce hydrogen, it's confirmed by the University of Southeast Norway, Professor Lars-Erik Gøy, that we are not violating the energy law or the entropy law, first and second laws of thermodynamics. And the reason why we can achieve this with a very cold output is because of this very endothermic SMR reaction.